Hello friends, let us start with carbon and important element. So what is an element? Element म्हणजे काय? So what actually are the different types of elements? What remains behind on complete combustion of any organic compound? And what type of element is carbon? Give some information about it. So what is an element? Element is the original substance from which everything is made. Okay? Element is the original substance from which everything is made. So carbon, hydrogen, oxygen, all these are basic things which build up the whole universe. Most of it is hydrogen. जास्तीत जास्त universe मध्ये काय hydrogenच आहे. Hydrogen that is present in the stars is converted into helium, and further on it is converted to carbon, nitrogen and other things. So what remains behind on complete combustion of any organic compound? So when any organic compound if you take and you burn it, then what happens? Only carbon remains behind. So what are the different types of elements? So different types of elements, they are metals, non-metals, metalloids, and carbon is a non-metal. So here you can see, so carbon is a non-metallic element. You have also learned about the occurrence of nature or form of different forms of carbon. So remember this, it is a non-metal. Now, if we take some milk and heat it in evaporating dish, then what will happen? A black color substance will be formed and black color substance will remain behind after evaporation of the milk, and that is nothing but the carbon that remains behind. तर तुम्ही जर ऑर्गॅनिक कंपाऊंड घेतलं आणि ते गरम केलं, जाळलं, तर शेवटी काय राहतं? कार्बन राहतं. So take small sample of sugar, wool, dry leaves, hair, seed, split pulses and plastic in separate test tubes. Heat each of these test tubes and observe the changes that are taking place. What does the black substance remaining in each test tube indicate? So if we take these sugar, wool, dry piece, leaves and other things and all, you take it in a test tube and heat. What do you see? ते सगळ्यात शेवटी काय राहते? कार्बन राहते. कार्बन एक बेसिक एलिमेंट आहे. कार्बन सगळीकडेच आहे. तर कार्बन चे इथं गोष्टी दिलेल्या आहेत बघा. सिंबल. सो व्हॉट इज द सिंबल ऑफ कार्बन? कार्बन इज C. Atomic number is 6, atomic mass number is 12, electronic configuration is 2,4, valency of carbon is 4, and it is a non-metallic element. So carbon is available abundantly in the nature. It occurs in free as well as combined state. Free state म्हणजे काय? फक्त कार्बन, दुसरं काहीच नाही. Combined state means what? Carbon reacts with another elements to form its compound. कार्बनचे जे नंतर compounds तयार झालेले. So in this chapter, we are going to study the properties of non-metallic element, that is carbon. So make a list of objects that you see daily life. रोजच्या जीवनामध्ये तुम्ही कुठले कुठले ऑब्जेक्ट बघता. Some of them will be metallic, some of them will be earthen or glass objects, and all other objects that you see, they will be containing carbon compound. So plastic bag, suppose your bed, your phone, okay, your clothes. These are the things that you encounter in daily life, and all of them contains carbon. त्या सगळ्यामध्ये कार्बन आहे, लक्षात ठेवा. Now carbon is a common and important constituent of all these substances. So what are compounds now? Now see, elements are unstable, and when elements react with another element, then compounds are formed. So compound obtained directly or indirectly from plants and animals are called organic compounds, and compounds obtained from minerals are called inorganic compounds. So there are two types of compound. One is organic, other is inorganic. So directly or indirectly from plants and animals, they are organic compounds, and those which are obtained from minerals are inorganic compounds. All organic compounds contain carbon. So carbon is the main element even in cellular DNA. Okay, DNA, RNA, all that contains carbon as the main element. Now hereditary characters from one generation to other, they are also transferred because of these carbon compounds. Okay, so introduction to scientist. German chemist Wohler synthesized an organic compound urea from inorganic compound ammonium cyanate. Okay, so German scientist Wohler synthesized an organic compound urea from an inorganic compound ammonium cyanate. तर हा जो जर्मन सायंटिस्ट आहे, Now, German scientists are very, very famous for their discoveries. Many of the German scientists have got Nobel Prize. So you might be knowing that Nobel Prize is a very prestigious prize, very high quality, high level prize that is given for high quality research in the scientific world. तर जर कुणी सायन्स मध्ये खूप मोठं काम केलं असेल, लाईफ चेंजिंग अँड फॉर द बेटरमेंट ऑफ ह्युमन काइंड अँड ह्युमॅनिटी, सो इट इज गिवन द नोबेल प्राइज. तर जर्मन केमिस्ट व्होलर जो आहे त्यांनी सुद्धा मोठं काम केलेलं आहे. आणि कार्बन वॉज so carbon was found to be main element, and he's also referred to as chemistry of carbon compound. Okay, तर मोठं काम केलं की नोबेल प्राइज मिळतो. Occurrence of carbon. Now, carbon is derived from Latin word that is carbo. Carbon is found in free as well as compound state that we know. कार्बन फ्री स्टेट मध्ये कसा सापडतो? डायमंड आणि ग्राफाइट हे त्याचे मेन इम्पॉर्टंट फ्री स्टेट आहे. फ्री म्हणजे काय? ओरिजिनल स्टेट. ओके. as carbon dioxide in the form of carbonates such as calcium carbonate, marble, calamine, ZnCO3, fossil fuels म्हणजे coal, petroleum, natural gas, carbonaceous material, carbohydrates, proteins, fats, natural fibers like cotton, wool, silk, all these are nothing but the different forms in which carbon is found. कार्बन वेगवेगळ्या फॉर्म मध्ये सापडतो आपल्याला. तर इथे दिलेलं आहे की फॉसिल फ्युल्स. फॉसिल फ्युल्स म्हणजे काय? पेट्रोल, डिझेल, केरोसिन हे सगळे फॉसिल फ्युल्स आहेत, जमिनीखाली सापडतात ना. दे आर फाउंड अंडर द अर्थ क्रस्ट अँड दॅट्स वाय दे आर कॉल्ड ॲज फॉसिल फ्युल्स. कार्बोनेशियस मटेरियल दॅट इज कार्बोहायड्रेट्स, प्रोटीन्स, फॅट्स आपल्या बॉडीमध्ये हे सगळे मटेरियल्स आहेत. नॅचरल फायबर्स दॅट इज कॉटन, वूल, सिल्क एक्सेट्रा. So you also can see that Earth's crust carbon is present to extent of 0.27%. Carbonate, coal, petroleum, atmosphere proportion of carbon is in form of carbon dioxide 0.03. Some types of plants which grow on ocean floor convert carbon into marine water into calcium carbonate. Now properties of carbon. Allotropic nature of carbon. Allotropy. Some elements occur in nature in more than one form, and the chemical properties are same but physical properties are different, so this is called as allotropy. So some elements they are found in more than one form, एकापेक्षा जास्त फॉर्म मध्ये सापडतात, and these are called as allotropes of each other. These are called as allotropes of each other. Chemical properties are different but physical properties are same. Chemical properties are different but physical properties are same. Example, carbon. So carbon is found in different forms like diamond, graphite. Phosphorus is found in different forms. Red phosphorus, okay, white phosphorus. Then we have sulphur. Sulphur is also found in rhombic sulphur, monoclinic sulphur. Like that, different forms are there. So allotropes of carbon. Crystalline form has regular definite arrangement of atoms. So what is a crystal? You have seen sugar crystal. So definite shape असतो. That definite form are there. Repeating arrangement of atoms. The atoms are regularly arranged. They have high melting point and boiling point. Now as they are regularly arranged, there is a strong bonding, and therefore what happens? Melting point, boiling point increases. Crystalline form has definite geometrical shape, sharp edges, okay, and plane surfaces. So three crystalline allotropes are there. Number one is diamond. So diamond is found in India mainly in Golconda and Panna, Madhya Pradesh. Diamond are also found in South Africa, Brazil, Belgium, Russia, and America. Structure. So in diamond, every carbon is joined to 4 other carbon atoms, neighboring carbon atoms. You can see the structure. So diamond has tetragonal 3-dimensional structure, which makes it very hard. Properties of diamond, you can see it is a, you can see here carbon. All these circles, they are nothing but the carbon which are joined to, every carbon is joined to 4 other carbon atoms. So brilliant and pure diamond is the hardest substance which is naturally available. Density of diamond is 3.5 grams per centimeter cube. Melting point of diamond is 3,500 degrees Celsius, and it is heated to 800. What will happen? It will react with oxygen to form carbon dioxide. Diamond does not dissolve in any solvent. It is no effect on acid and base, so acid base do not react with it. and it is a bad conductor of electricity. Okay, it does not have free electrons. So just go through these properties. Remember, it is the hardest substance in the nature. Melting point, boiling point, they are very high, and does not dissolve in anything. It's not reactive. Acid base have no effect on it, and it's a bad conductor of electricity. Now uses, of course, it is used in jewelry. So ornaments, for making ornaments, you know. Then it is used for glass cutting and rock drilling machines. So very big rocks, very strong rocks. Okay, so if you have iron or other things, they may break, but diamond heads will not break. So drilling machine, at the tip, we have these diamonds. They are special type of diamonds. They're not very shiny, but they are specially made for drilling machines, and they can cut the rocks. Okay, cut the glass and drill the rocks. So however strong or however hard the rock may be, so you can drill it with the help of these special type of diamonds. Okay, now diamond knives are used in eye surgery. Diamond dust is used for polishing other diamonds. Diamond is used for making windows, giving protection from radiation in space and artificial satellites. Now graphite. So graphite is another form of carbon. It is found in Russia, New Zealand, America, India. It is used in pencils mixed with clay, and it was discovered by Nicholas Fontaine 1795. You can see the structure. Every carbon atom in graphite is bonded to 3 other carbon atoms in such a way that hexagonal layer is formed. A graphite crystal is made up of many sheets or layers, and the layers slip over each other applying pressure. One layer of graphite is called graphene. बघा बरं, कार्बनचे atoms आहेत, hexagonal layer तयार होतात. Graphite and structure of carbon atoms in graphite, you can see hexagonal layered structure is there. Graphite crystals made up of many sheets. So these are carbon atoms one over each other. Now, apparatus: pencil, electrical wires, battery, cell, bulb, water, kerosene. All these things are required for an experiment. You can see the picture. You can remove the wooden cover over the pencil. You can assemble the apparatus as shown. And when you pass current through it, then what will happen? The bulb will glow. Take some water in a test tube, take some kerosene and other, put the lead dust in it, and what do you find? So to understand the properties of graphite, we are doing this experiment. So graphite is found in nature as black, soft, brittle and slippery. Inside each layer of graphite, free electrons are present. So in every layer there are free electrons. As there are free electrons, they can carry electricity. So it is a good conductor of electricity. Graphite जे आहे, actually carbon 4 bond तयार करतो, पण इकडे 3च bond आहेत. You can see the structure. Only 3 bonds are formed by every carbon. So 1 electron is free, and that is moving in the layers, and it can carry the electric current. So be good conductor of electricity. Due to layered structure, it is used for writing on paper. Density is 1.9 to 2.3. Graphite does not dissolve in most solvents. And where it is used? It is used in pencils for writing. Lubricant. Now what is a lubricant? When we have machines, and those machines, they have moving parts, so they have a friction in them. When we want to reduce that friction, then we use lubricants. Lubricant नि काय होतं? Friction कमी होतं. It is used in paints, polishes, and it is used in arc lamps also, which gives us very bright light. So very bright light could be obtained by graphite. Then we have next is fullerene. Look at the picture. इथं picture बघा एक कसं आहे, buckyball. So this is carbon 60. Carbon 60 म्हणजे काय? 60 carbon atoms. There are 60 carbon atoms joined to each other. So fullerene is an allotrope of carbon. Diamond, graphite, fullerene. These are allotropes of carbon, forms of carbon, rarely found in nature. So it is found in soot and in interstellar space. In the first example of fullerene, that is Buckminster fullerene, this allotrope is after the architect Richard Buckminster Fuller. Okay, so